Cool. I'm pretty sure the next talk is going to be very relatable as well as very impactful for most of you. How many of you have had a bit of a heartache because of an AWS bill? Okay, I see a couple of hands, couple of relatable pains. I'll put another scenario here. How many of you have dealt with a client who wanted twice the performance or twice the capacity, but not twice the cost? Right? I'm sure there are quite a few. So Arnab is going to help us understand that entire scenario and how we can save face with some of those tasks. Over to you, Arnab.
Hello, I'm audible? Loud enough? Good day, Kochi. How are we doing? Thank you. Well, I'm amazed once again. This is extraordinary. The way this session has been contented, the whole event, people come together, the quality of speakers, content, it's mind-blowing. Now let me start up with a story here. Before that, I'll introduce myself. My name is Arnab Chatterjee. I head platform engineering in my company, Nomura, which is a financial company, primarily focusing on cloud and containers. So I flew from Mumbai, by the way. Somebody mentioned that we had a gentleman who flew from Sri Lanka, but the beauty of the country is that we have an international traveler who took less time to reach Kochi compared to me, who lives in the same country. That's the beauty of the country. So while I was flying in the morning, I found the first seat, and I thought of just brushing through my presentation. And there was a gentleman next to me, right on my right, a serious-looking, middle-aged, respected gentleman. I sat next to him. I opened my laptop. And immediately, I caught his attention for whatever reason. And this was a slide that I brought up. And he asked me, "Son, what do you do?" I introduced myself. He immediately brought into attention the Frugal cloud. Can cloud be cheap? I said, "Sir, I'm trying to put a pitch where I can show how it can be less expensive." By the way, what do you do, sir? His response was, "I'm a CFO of a company that manages data center." I had to take a pause. I said, "Fine." He asked me again, "Don't you think running your workloads on data center is cheaper?" To which I said, "I did give an answer, but I'll keep the suspense till the end of the session. Let me get started with the session now." Let me start with a confession about cloud. So when I started my journey in public cloud, I initially thought it would be all sunshine, rainbow, and infinite scalability. Wow, that was fantastic. But in reality, it had a magic. Yes, it did have a magic. The kind of magic that would let your wallet disappear faster than your socks would disappear in a laundry. On one hand, you're trying to deploy a web application on cloud, and another instance, you might be renting out a house to pay the EC2 bills. Now, that's a bit too much. But let's make it a fact. When you enter AWS, it feels like a candy store where you see so much of Indian sweets. I would say candy rather than Indian sweets. But moment you start experiencing it more, you initially see that it's compute, databases, caches, document store, everything. And it's like, you've inherited a monument, infrastructure, heritage from your family, and with click, 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 you provision everything. But the moment you get the first bill at the end of the month, it is dreaded. Only if you overcome it for the first time, the next month is not far off. And when it nears, this is exactly how you feel. But let's not get afraid. Today, I'd like to touch base upon a few very important strategies or other approaches that will help us to optimize cloud. Yes, you can run your workloads in AWS and not leave a hole in your pocket. You can definitely right-size your workloads with few approaches and smile happily. Hopefully, by the end of the session, we'll be taking home some useful tips and implement it in real life. I'm going to talk about the 7 commandments of making this successful. I'll keep it very simple, straightforward, without much ambiguity. Commandment number 1, Very simple, basic, right sizing. Yeah. You know about AWS, you know? It's mainly people talk about running your workloads. It's about the EC2 instances. EC2 instances, that's not a small bouquet. In reality, it's probably 10 times more options than what you get in a Starbucks shops when you choose out of your loving coffees. You have different instance type and instance families. So there are certain options available to you to run your workloads which are compute intensive, some are storage intensive, some of them needs burstability, some of them are like staggered. So there is a lot of option to choose. But the question here is, how do you know what to choose and how to choose? That's where certain utilities come into the picture. Without advocating any third-party software, I've taken an example of AWS Compute Optimizer. There are tons of FinOps products and utilities in the market that will give you wider insights. But let's take an example of AWS Compute Optimizer. What it does, it's basically nothing but a recommendation engine for your workloads that would run on AWS on your resources. To start with, optimizing your EC2 instances. Understand what is the compute capability. Are you under-provisioned? Are you over-provisioned? Whatever you're running, is it good enough or is it too small? What about the network capacity? Is it getting throttled or is it not even getting utilized? Your storage footprint. Are you actually using your storage efficiently? What are your access patterns? Is the stuff that you store is on the right tier? Are your auto-scaling groups rightly configured? Your serverless components, are they being tuned right? How do you come to know about this? You use such optimizers to determine the same. For a good example, if you don't know what is the nature of your workload, the optimizers will give you a recommendation that, okay, you don't need to run this t-shirt size, you go for this t-shirt size. Based on the nature of the workload, it will recommend you better options for a better outcome. Similarly, if you are dwelling some of your workloads on a serverless component like a Lambda, and you're driving Lambda based on your assumptions on how much memory it will use, it will recommend you the same if you're not on the trap. Similar thing for storage, and similar thing for network bandwidth. So basically, understand your requirement, understand what you need to run efficiently and in a cost-effective way. Apart from that, there could be a lot of your workloads that are burstable, that needs to run on peaks in certain hours, leverage auto-scaling. Now, either you are running simple vanilla workloads or containerized workload, there are different ways of handling it with a mixture of auto-scaling group or leveraging modern autoscalers like a Carpenter, where you can bloat and shrink based on the demand, based on the peaks. Knowing insights, using the optimizer, and then apply on it is the step number one. The second commandment, I would say, is spot instance. We spoke about right sizing, right? There is an analogy that says when you go to buy milk, 1 gallon milk, you don't carry the tank with you. So what do? You right size, correct? But even after right sizing, if the numbers are really not very rosy, you want to improve further, what do? So I know people are aware of spot instances, but this is very important to bring the spot instances of AWS into the mix. Now, what are spot instances? As you all must be aware, they are the same EC2 instances, but are 90% cheap. Now, that's easy, isn't it? Why don't people use it? Well, that is a catch. There is no guarantee that it won't be taken away. It's like, the game of musical chairs, where your instances are moving around the musical chair when the music goes on. Moments it goes off, one of them disappears. Now, what kind of workloads can survive with spot instances? Have you recognized your footprint, the blast radius of the same? There are certain use cases that are very well suited to run on spot instances, like if you have a distributed computing job, if you have a batch processing, if you're doing a CI build to push your artifacts, or you're doing big data analytics, AI or ML, that can survive with spot instances. To use and manage spot with EC2s, in earlier days, you probably would know how the spot happens. The only good part about spot is, even if it is taken away, it gives you an interval notice. It will give you a couple of minutes notice in advance that I'm being taken away. So you can catch the interruption and do a logic of swapping and swapping out. With modern workloads running on Kubernetes, uh, things like frameworks like Carpenter are already spot aware. You can mix them up with on-demand and Spock, and it's intelligent enough to replace it on demand when it goes out. So the number 2 point is leverage spot instances, identify what workloads can move to spot instances, and bolster them. When we were kids, we were repeatedly told by our parents, whenever you move out of the room, switch off the light, switch off the fan. We used to follow gracefully. Nowadays, there are smart lights and smart fans where you don't do that because some homes, I know, not many, probably hotels, you go out, they shut on of their own. It's very similar. It's nothing different in AWS. If you leave your instances on, it's like leaving your car engine on for the entire night, the fuel will fade away. So it's very straightforward. Turn things off when they're not in use. But easier said than done. This is a world of automation in this era. How would you resort to something being manually triggered? It absolutely doesn't make sense. Triggering shutdowns, there are a lot of ways of doing it using frameworks, but just for an example, I'm just giving a simple example of an AWS Lambda that can check for idle instances and then shut them down. A scheduling of EC2 stop-start using event based on a cron time slice, etc., etc. Same would hold for RDS. So this third point is very, very basic. Shut down things when they are not in use. This is very basic. There could be multiple ways of doing it, but please adhere to this. Even a silly mistake can wipe out your bank balance. Now, commandment number 4, most ignored, I would say. S3 is the de facto storage system for anything that's cloud native or in cloud. But the perception of S3 is unlimited have enabled people to create a garbage bin of stuff out of it. So they actually are not aware of S3. They talk about S3 buckets and buckets and buckets. Advantage of S3 is that you grow awareness about the type of storage you are going to work with. So as you see on the slide, there are the different variation of different S3 categories. So you have S3 standards, which is prominently used for active frequently accessed data. Then you have a standard 1A for the little infrequently. Moves a couple of steps on the right, you see less frequently, and then you have Glacier and flexible retrieval. There is a concept of S3 lifecycle configuration where you can set up policies based on the use case. If you've identified that and you're aware of what kind of data patterns and access patterns move across it. So if you know that certain data should not be accessed or would not be accessed after a certain period of time, you make rules to move it to a different tier and then to Glacier. If you're not aware, you are skeptical about the nature of read, writes, and I/O, use S3 intelligent tiering, which will do the job for you. So S3 lifecycle management is very important, and it will reduce your storage consumption to a very, very high degree. It's the most ignored stuff I've seen because people only focus on compute. They only focus on EC2 instances and auto-scaling and reducing cost. They forget about the S3 lifecycle management. Reserved instances, yes. How many people have this feeling when they go to a store like a DMart and Costco, and they get a massive discount when they buy something for the entire year? Like you buy tons of toothpaste or grains or oil in bulk quantity, and you get a 75% discount. Sounds good, but the challenge here is that you have to commit to a particular pattern. Reserved instances will give you a discount. They will give you very heavy discounts, like around 75%. But for you to commit to reserved instances, you need to know that how much percentage of your workload are consistent. A good example is if you're running databases, obviously you don't really go for down and upscale and things like that. It normally will have a consistent run. And those are the kind of pieces where you can trust. If you have other workloads which you have monitored, measured over the period of time, and you are pretty sure that this is the footprint, this is the instance type, this is the instance family that is going to use for the next 6 months or a year or more, you could go for reserve instances. Sometimes locking for 3 years is a bit more premature because if you choose the reserve instance type try to get a bulk, massive amount of saving by putting a long rope. You might actually repent because the way things change nowadays is very fast. The dynamic of things are very, very frequent. They're volatile. So rather than doing that, it's better to take a savings plan and monitor for 6 months and then took a staggered approach, which allows you to choose a combination of a savings plan with the right instances and do optimal amount of saving. There are certain reserved instance monitoring tool that will give you insights for specific instance that you can mark as monitor them because I think they can be good candidates for reserve instances. So yes, that's the another option. Moving on, I think everybody is aware of this. Graviton 2, it was AWS's Go Green initiative to reduce carbon footprint. There's a saying, you know, when chips are down, and then they change the saying, when chips are down, buy a new chip. It's basically ARM-based new processor which consumes low energy, and it gives massive performance. So basically, if you're using Intel family processors, you combine or compare it with the Graviton processors, if you're getting a X-core hyper-threading compared to that a Graviton, the same value you will get for a lot cheaper, probably a 20% lower cost. Graviton is very, very suitable for workloads that leverage multi-threading. So for example, if you are running microservices and Kubernetes kind of workload, then Graviton is the right choice. However, leveraging Graviton is a bit of a change in approach. You need to use the Graviton-compatible AMIs so that it supports it. Your CI pipeline that builds the images or the binaries needs to be built on Graviton machines so that they're Graviton compliant. So that is a bit of a work that you would need to do at your end, but it's a massive gain, specifically when you move your workloads, high-powered workloads, where you need heavy compute at a lower cost. As you can see, you know, it gives you up to 40% better price performance compared to x86-based instances. Analogy, it's like, you know, it revolutionized the way computing happens, the way electric cars came in compared against the petrol cars, and way Tesla came in among the electric cars. So I would say ARM did the bit with the external processor, and Graviton did the other way side. And so yeah, that's the thing. And the final thing, important piece to take care of is all these things are all fine, but repeatedly, one more time, you need to explore what's going on. You need to keep on monitoring things to identify what is the data that needs to be pivoted. In specific time example, you need to do predictions, forecasting, etc., etc. AWS Cost Explorer is an example, but as I said, there are various other FinOps tools that bolsters the need of the people. So if you use these 7 commandments, I think you will gain a lot. I would want to just show a real-life case study where this use case leveraged all these practices and saved a good amount of cost. So this is a case study where we had a SaaS company. It was running hosting services for different clients. Apparently, the whole application stack was deployed on Kubernetes on an EKS cluster on AWS. The number of clients grew exponentially over the period of time from 10 to 100 and kept growing, and so did the cost. So what started as a dream was turning out to be a nightmare, and then they started pondering on how to improve the ROI, how to make sure the bill doesn't really go skyrocket. Again, 7 commandments. So what they did is they used one of those FinOps utilities. I won't really take the name. They actually used a combination of 2 of them. And then they looked at the EKS node. They realized that the gamut of things was very varied across the whole cluster. So they were running microservices, they were running batch processes, they were doing a reconciliation job, they are running machine learning. So every single client had different requirements. Some had a mixture of both. And they were strongly isolated from each other. So every tenant had its own footprint. It was a multi-tenant cluster, namespace-based multi-tenant tenancy. They found out that the node pool of the EKS cluster was not correctly configured. The instance type and the instance size they used were highly overrated because they tried to do a one-size-fit-to-all. They started with that approach, but with growing things and changing dynamics, that got flawed, and they were unnecessarily paying a lot of money with hardly 20 to 35% of utilization. So what they did is they made sure that they reconnected the nodes, the EC2 instances, node pools and node groups, and resized them to the different needs. There were certain pods that had affinity to certain workloads and certain nodes. They figured it out, did the FinOps well, and mapped it correctly. They leveraged auto-scaling, which they didn't do day one. They had pre-configured a large fleet. They moved away from it. They brought in Carpenter. They educated Carpenter to make sure that it uses a good combination of on-demand and spot instances based on the nature of the workloads running in each tenant. And that allowed them to bolster their optimized performance and lower down the cost. So when it would auto-scale based on the nature of the process, and it would either bloat out the spot ones on the peak, or it would do a combination, while the long-running zero-downtime services use the standard instances. So it actually was a divide-and-conquer approach, which allowed them to further navigate and find out the right sweet spot. Rather than doing what they were doing earlier on, it's like cracking a nut using a Thor's hammer. I'm a big fan of Avengers, so it directly comes to me. They also realized that some of the workloads of some of the tenants were like very, very minuscule. Where they did give certain namespaces to certain tenants, around a dozen of tenants were like hardly even utilizing a fraction of that. After consideration and looking at the nature of workload, they found out the workload was not really related to storage and persistence. They're completely stateless, ephemeral. So they moved those workloads to Fargate for serverless Kubernetes specifically. And again, they saved good amount of cost by squeezing out those namespaces. Again, S3 and EFS, as I mentioned, in EKS, they had primarily two different kind of storage layers. One was EFS and one was S3. What we spoke about, the S3 was getting dumped with a lot of data that was not getting tiered. They applied the same policies. They benefited out of it. And then for EFS, they used interval-based optimization, where a less accessed storage footprint would be moved to a lower tiered volume, saving more cost. And finally, a lot of node groups were found to have a very, very consistent runtime. So decided to have a good amount of instances swapped by reserved instances. Those purchased a good saving plan for the next 6 months, lowering the cost and benefit them to a higher value. So in a nutshell, using the 7 commandments, this company was able to reduce their cost by 40 to 45%. So in the next budgeting cycle, they use that amount to get invested into some new initiatives. Now, coming back to the starting question of the gentleman in the flight who was sitting beside me. The question he asked was, isn't data center cheaper than cloud? This is what I answered. With that, I would want to conclude. Thank you.
Thank you. I hope everyone was using AWS at least day-to-day life, and it was an informative session.
Thank you.
Don't turn on your flow logs and store in CloudWatch especially. We have a token of appreciation.
Thank you.
Thank you so much for coming.
Thank you.